Greetings to every one of you. In this video, we are going to discuss another very important concept from machine learning, that is self-organizing map, SOM. First of all, we will see the explanation with an example and how this method works, its working procedure, followed by the different steps of this algorithm. This is also called Cohen maps. It follows an unsupervised learning approach and trained network through a competitive learning algorithms. It is used for clustering and mapping the multi-dimensional data onto a lower dimensional data. So the dimension reduction can be possible with this algorithm, so which allows people to reduce the complex problem for easy interpretation. Basically, SOM has two layers. So one is input layer and another is the output layer. So input layer contains the input data and output layer contain the clusters. SOM with two clusters and n input features of any sample given below. So we have these are the input data. So each one is a sample, that is example, and these are the two clusters that is available. And here we have weights for all these clusters. So the weight, that is W01, the weight of the first sample 0, which connects the cluster C0, that is 00, and similarly that is weight of the first data, that is X0, connected with the cluster, that is C1, that is 01, W01. Similarly, the weight of the cluster data 1 connected with the cluster 0, that is W10, and similarly the weight of data 1 connected with the cluster 1, that is W11. Similarly, let us consider we have n number of data, so the weights can be, that is given as Wn0 and Wn1. So the second value represent the cluster value. How does this algorithm work? Let us consider an input data of size m, n, where m is the number of training example and n is the number of features in this example. First, it initializes the weights of the size n, c. C is the number of clusters. So as I said, in this case we have it is n number of input data and we have two clusters. It performs iteration on this input data, and for each training example, so it updates the winning vector with the shortest distance. So it calculates the shortest distance using the formula, that is Euclidean distance. So we know that the formula, it is the Euclidean distance, it is equal to between these 2 points, that is P1, P2, can be written as square root of x2 minus x1 whole square plus y2 minus y1 whole square. So the weight updation rule is given by Wij is equal to Wij of this, its previous value, plus alpha of t into xi power k minus Wij of this previous data, that is old data. Here this alpha represent the learning rate at time t, and the j represent the winning vector, and this I is the ith feature of the training example, and k is the kth training example. So after training the SOM network, the training weights are used for clustering new example. A new example falls in the cluster of the winning vector. So finally, all these the initial values will be changed with the help of this new values. So algorithm of this SOM. Step number 1, initialize the weights Wij using random values, maybe that is assumed. Initialize learning rate alpha. Step number 2, calculate the squared Euclidean distance. We have to calculate the Euclidean distance, and that value must be squared. So here d of j is equal to summation of I is equal to 1 to n Wij minus xi whole square, where I takes values from 1 to n and j takes values from 1 to m. For example, if consider if d of j is equal to 1, d of 1 is equal to w11 minus x1 whole square plus w21 minus x2 whole square plus w31 minus x3 whole square, etc. wn1 minus xn whole square. So this will be discontinued for m number of times. Step number 3, find the index j when d of j is minimum, that is considered as the winning index. So comparatively, we have to compare the values which this index value is less, and that will be considered as the winning index. Step number 4, for each index j within a specific neighborhood of j and for all I, calculate this new weight. So the new weight can be calculated with the help of the formula Wij of new is equal to Wij of old plus alpha into xi minus Wij of this old. So update the learning rate by alpha t plus 1 is equal to 0.5 into t. Step number 6, test the results and you can stop. So in this video we have discussed about the explanation of this SOM method, how this it works, its working procedure, and also I gave the various steps of this algorithm. I hope you understood the concepts. Keep watching. Thank you.